Hey everyone, Alexei is here. Today we're tackling one of the most frequently asked medium coding interview questions from LeetCode. Best time to buy and sell stock, number 2. And you'll see two different optimal solutions, both simple and with guaranteed linear runtime. You are given a list of stock prices over several days. To make it more visual, let's represent it as a graph. You can buy and sell as many times as you like, but you are only allowed to hold one stock at a time. How do you maximize your total profit? As I mentioned before, we have two different optimal solutions to this problem. Let's start with the most intuitive one based on tracking local minima and maxima. To make the most money, you need to buy a stock every time right before its price starts rising and sell it right before it starts falling. So if we buy on day 2 for $1 and sell on day 3 for $5, we earn $4. Then we buy again on day 4 for $3 and sell on day 5 for $6. Then another 3. Altogether, the maximum profit we can make is $7. And now let's implement this. First of all, we create a variable called profit where we'll store the total profit we make. Then we define two more variables, min and max, and initialize them with the first price in the array. Next, we start a loop from the second element and go through the rest of the array. On each iteration, we check if the current day's price is higher than max. If it is, that means the price is still going up, so we simply update max and continue. But if the price is lower than max, it means the upward trend has ended and the price started to drop. At this point, we commit the profit and simulate selling the stock at the previous day's price. That's why we add to profit the difference between max and min and reset both of them to the current price. After the loop ends, we might still have an open trade if the last price was part of an upward trend. So we do one final check and add the last max minus min to the total profit. And finally, we return the profit value from the function. So let's talk about time and space complexity. We go through the array exactly once using a single loop, comparing each price to the previous maximum. Each operation inside the loop takes constant time, no nested loops or recursion. So the time complexity is big O of n, where n is the number of elements in the array. As for space complexity, we're not using any extra data structures, just a few simple variables, profit, min, and max. So the space complexity is big O of 1. This approach works well, but it looks a little bit messy. Let's explore a cleaner alternative. Instead of trying to find every peak after a dip, we can just move through the array and add up the profit each time when price rises. As in the previous solution, we start by creating a variable called profit, which will store the maximum profit we earn. Then we loop through all the elements in the array, but skip first element. On each iteration, we check if the price on the current day is higher than the price on the previous day. If it is, we add the difference between two prices to profit. In other words, we collect profit every time the price goes up, one small gain at a time. At the end of the function, we simply return the profit as a final result. A quick note on the complexity of this method. It's identical to the previous one. Since we iterate through the array just once, the time complexity is big O of n. And because we only use a single variable to store the profit, the space complexity is constant. And that's it, we solved the problem best time to buy and sell stock number 2. I hope you found this video helpful. If you did, feel free to drop a like and see you in the next one.